Director at Hadek Protective Systems. He joined Hadek, which specializes in the internal protection of power plant ductware and chimneys. During his work with the organization, he has gathered extensive experience using thin film lining systems and borosilicate glass block lining for ductware and chimneys. He has also been closely involved with a number of technical studies on the use of borosilicate glass block lining. He has worked closely with the various practical aspects of using these linings in the fields. Mr. Albert is a business economics graduate from Erasmus University. I welcome you again to the conference, sir, and you have the presenter rights. You may start with the presentation.
Thank you very much. Am I audible to you?
Yes, Mr. Albert, we can hear you.
Very good. Thank you. So thank you very much for giving us the opportunity to do this presentation. It will be only a brief and very practical 20-minute presentation. We'll be speaking about one very specific aspect of our borosilicate lining technology, which is the behavior of this lining technology in wet stacks from the environmental point of view. If we may, we will now start up our presentation and take over the screen. Is the presentation visible?
Yes, sir, the presentation is visible.
Very good. So I will start with this. Okay, so the title of the presentation is a new technology for safe operation of wet stacks at full plant capacity. And it will address the problem of spitting that can occur when a power plant runs a wet stack downstream of a flue gas desulfurization plant, especially when the velocity becomes too high. And before I go into the presentation itself, I would like to speak briefly about the problem of spitting. What spitting is, of course, and most in our audience will know this very well, it is the ejection of acid liquid droplets from an FGD wet stack into the environment surrounding the power plant. And this spitting can rain down on the environment surrounding the power plant, so on the plant itself and on neighboring villages and crops, and it can be extremely damaging, so it has to be absolutely prevented. Now, our company is a supplier of internal lining systems for power plant chimneys. We specialize in the field of borosilicate glass block lining systems, and we are already supplying to several projects in India. We have now developed a special technology that will help FGD wet stacks to be more safe against this problem of spitting, even at higher velocities. So what I'll be talking about is what we call the 45-degree high velocity pattern of the lining for FGD wet stacks. It is a special way to install these borosilicate glass block linings so that they will drain the liquid from the wet stack better and more safely, even at higher velocities. To give you some background, there are different materials that can be used on the inside of a chimney, certainly on the inside of an FGD wet stack. And here is a listing of the most important systems by US EPRI, the Electric Power Research Institute. And for each of these systems, acid brick, alloy, FRP, borosilicate block, and also for coated steel flues, the EPRI gives a recommended velocity that can be used. So if we go to the category that we are talking about, which is the borosilicate glass block, we see that the recommended velocity in an FGD wet stack maximum is 18.3 meters per second. So if we go faster than 18.3 meters per second in the FGD wet stack, this spitting problem will start. Now, of course, this is quite a strong limitation, and quite a few customers have power plants where the chimney velocity can actually be higher than 18.3, and they need a good solution for this. And that is why we developed this 45-degree high velocity pattern. Here we see that in order to develop a lining system that allows greater velocity, we tested a number of different varieties. On the left side, which we call panel 1, you see the normal lining system, the normal borosilicate glass block lining system, where the blocks have been placed in an upright position. This is the way we normally use the system, and this is the system that has the limitation of 18.3 meters per second. So I will not speak specifically about each and every panel. That would take too much time, but you can see that we tried to different varieties where the blocks were installed with different shapes and sizes and under different angles. And each of these panels were tested for their behavior in a wind tunnel with liquid present. It's a standard test procedure done by this special company from the USA, Holden. So what we found is that this is the variety that has the best properties for wet stack liquid draining safety. It's the 45-degree high velocity pattern. And so what it means is that we install the blocks using this special pattern. And I'll show what the results are. So as I had mentioned before, the conventional lining system has a maximum velocity, a maximum allowable velocity of 18.3 meters per second. Now, if we use the lining system in this new pattern, the recommended velocity goes up by 3 meters per second, up to 21.3 meters per second. So the allowable velocity is much greater. I also want to mention that the first project has been done now in India using the 45-degree pattern. It is the NTPC Bar 1 power station in Bihar state. This power plant has a chimney with an existing steel flue. It needed to be lined with a borosilicate glass block lining system, and we are using the system in this pattern to make the chimney more safe against spitting. So I'm coming already to the final point of this presentation, this special pattern. First of all, I do want to mention that the extra cost of the special pattern is basically zero, because the same materials that our company supplies and can be used, and the work productivity is nearly the same. So we see actually that there is very little or no additional cost from using this pattern. So it is a very good improvement of the wet stack environmental safety. And definitely we have identified 3 cases where the use of this pattern should be considered. Number 1, if any customer wants to line an existing chimney where the flue gas velocities will be higher than 18.3 meters per second, we recommend to use this system, the 45-degree pattern, to make the chimney more safe. The second point, chimneys where increased gas volumes can occur. And this is a very important one, because we see many customers who have dimensioned their chimney nicely for 18.3 meters per second in the most common operating case, which is guarantee volume. But when the plant is operated at design point, i.e. when the market demands that the power plant is operated at 100% capacity, then the gas volume can increase. And we have identified quite a number of power plants where during such full load design point operation, the gas volume is much higher, and gas velocity in the chimney will be well above 18.3 meters per second, sometimes 20, sometimes 21 meters per second. So for those cases, we recommend to place our lining system in the 45-degree pattern also. And finally, we recommend to use the 45-degree pattern for chimneys with unstable gas entry velocities, where the duct geometry is such that there is an imbalance in the gas flow going into the chimney, leading to localized high velocities in the entry area. So that is my presentation. It is short and practical, but I think it can be important for quite a few customers in India and in other countries. Thank you.
Thank you, Mr. Albert, for your very interesting presentation. I will now move on to the questions. So before I take the questions from delegates, a few questions from my side. So what should be the key criteria that should be considered by utilities in selecting the lining systems?
Well, of course, number one, the provenness of the lining system in actual operating conditions and the proven success of the lining system. Number two, the professional ability of the supplier to supervise and technically support the installation to make it a success in the field, because a good material is only a good start, but good installation is absolutely necessary. And yes, thirdly, the environmental properties of the lining are important, because even if a good lining does not have good environmental properties, then there will be spitting, and the power plant will have huge problems fixing this, because there will be great damage in the surrounding communities. So those 3 points, quality of the lining material, provenness of the lining material, the technical ability, professional ability of the supplier, and thirdly, the environmental properties of the lining system.
I'll move on to a few questions that have come in from the audience. So how to check the power plant FG wet stack meets the 45-degree high velocity pattern?
Right. So the best way to do it is to look at the maximum gas volume that can occur inside of the chimney. So typically this will be the gas volume in actual meters, actual cubic meters per hour or per minute during design point operation. And then to look at the net diameter of the steel flue, and this is a matter of simple calculation to determine the expected flue gas velocity. If it is higher than 18.3 meters per second, then we recommend to consider the 45-degree pattern.
Okay. So moving on to the next question, sir, is there any additional benefit of using this lining pattern in terms of saving from reduced chimney diameter?
So yes, it is of course possible. If this lining system is used in the 45-degree pattern, it is possible to make the chimney diameter a little bit smaller. So in order to adjust, and as I had shown, as long as the flue gas velocity is not more than 21.3 meters per second, the operation will be environmentally safe.
So moving on to the next question. So what is the effect of uneven RC surface inside the chimney? How can this be addressed?
I'm so sorry, because your sound connection is intermittent, so I couldn't properly understand the question, please.
What is the effect of uneven RCC surface inside this chimney of application for block, and how can this issue be addressed?
I'm sorry, I still didn't. I did not get it. I'm reading now. Aha. Right. Yes, I believe I now have the question. What is the effect of an uneven surface? So, if we are talking about a steel surface that is uneven, then there is no immediate effect. The steel will, of course, have some bulges, and this is normal, and the lining is applied naturally over those bulges. If we are talking about a concrete surface, which is occurring in our so-called new chimney design, then we recommend to make the surface even by troweling it first with a cement grout and only then to install the lining system itself. But in any case, small unevenness can always be addressed by the compensating effect of the adhesive, because the adhesive is applied typically in a thickness of 3 millimeters behind the blocks, but it can be thicker if the irregularity of the surface requires that. It can be up to 6 millimeters without any problem.
Mr. Albert, am I audible now?
Yes, I hear you.
Yeah, okay. So I'll move on to some other questions that we have received. Now we are talking about the pattern will allow greater flue gas velocity. What is the principle behind this?
So, yes, the principle behind the 45-degree pattern is that if we apply the lining in this fashion, we have found that it drains the liquid much better. So the avoidance of the horizontal joints that are occurring in the standard pattern is the key aspect of the difference, because if we have the horizontal joints, then liquid which is streaming down will tend to collect on these horizontal joints, and there it will form thicker layers, and that can be blown off the chimney surface. So if we are working with 45-degree angle on these joints, then the liquid runs down these joints much more smoothly, and as a result, the velocities can be higher. So, of course, this is the theory, but we found it as a practical result during this test program. And if you would like to have a visualization of the principle, I would like to recommend to visit our website, because we have a video on this 45-degree pattern where it is shown quite well. And with the video connection allowing, you can see there a good animation of the principle, and I think it will be very clear.
So before we end this session, I'll just take one last question. What can be done in case the chimney of the power plant is already installed, but will have more flue gas velocity than allowed for borosilicate lining?
Yes, so this is a very important point. I had shown during my presentation the Bar 1 power plant in Bihar, and this is exactly such a case. The chimney was already existing, and with the gas volume coming out of the flue gas desulfurization, the velocity in the chimney was going to be in the order of 21 meters per second. Clearly, indeed, it was not possible to use a borosilicate lining in this chimney in the normal way. And the 45-degree pattern was the solution, because it allows for a greater gas velocity. Of course, we have to consider the limits of this system also. We have found that above 21.3 meters per second, there is an increased risk of liquid entrainment, spitting, even with this system. So this new technology does open up quite a lot of options for existing chimneys, but we have to check every case individually.
So before we end the session, just one more quick question which has just come in. So can there not be a primer and adhesive for borosilicate which can be stored under normal temperature and pressure?
Well, the adhesive that our company supplies can be stored under normal temperatures. By that meaning around 20 to 30 degrees C under stable conditions. The only part that needs to be considered very carefully is the hardener of the adhesive. This is a small bottle of isocyanate, and it needs to be stored at steady room temperatures. But this is not such a huge problem because the volume is small. So even for a large project, we are talking maybe about 2 or 3 pallets of this material, and it's usually quite possible to find a good storage where the temperature is stable and not too high. So I'm not sure what your audience question was aiming with special pressures or special temperatures. In the case of our company, that is not a requirement.
On that note, sir, we will end this session. Thank you so much for joining us today for a very interesting presentation and an engaging discussion as well. Thank you once again.
Thank you. Bye-bye.